Hello, friends. This is the AlphaList podcast. I am your host, Toby. The goal of the AlphaList podcast is to empower CTOs with the info and insight they need to make the best decisions for their company. We do this by hosting top thought leaders and picking their brains for insights into technical leadership and tech trends. If you believe in the power of accumulated knowledge to accelerate growth, make sure to subscribe to this podcast. Plus, if you're an experienced CTO, you will love the discussion happening in our Slack space where over 600 CTOs are sharing insights, or visit one of our events. Just go to alphalist.com to apply. Welcome to the AlphaList podcast. I'm your host, Toby, and today with me is Eiso Kant. And Eiso is the CTO of Poolside, which he built together with Jason Warner, whom I'm happened to interview in episode 21 of the AlphaList CTO podcast. Back in the days, he was still CTO at GitHub. So, Jason. So, how did it come that you teamed up with the former CTO of GitHub?
Oh, there's actually a bit of a story there. So in 2016, I was building a company called Source. And to the best of my knowledge, Source was the world's first company that focused on making AI capable of writing code. And by the end of 2017, we had code completion models working and several other things. And Jason spotted this and made an acquisition offer from GitHub to Source to try to buy the company. I turned down the offer, but nonetheless became very good friends. And that's obviously quite a few years ago. And since then, we stayed in touch. We ended up having a podcast for 3 years together ourselves as well, which is just a great way for two grown men to find themselves on a regular schedule meeting. And and throughout that, we ended up becoming incredibly good friends. And so when the world kind of had its warning signal of ChatGPT launching in terms of how it was about to change, it was a very natural evolution for us to turn those post-podcast conversations into what's the world going to look like and what are we going to do in that world.
As of today, are you sad that you didn't sell Source to Jason back in the days, or?
I've never been much for regrets. I think from a financial outcome, it would have had incredible consequences, but I'm actually very happy I didn't. Source was too early and we didn't succeed. And for several years, that looked like I was wrong about the future. I had a very, very strong belief that models were going to be able to reach human-level capabilities across software development and beyond, and looked like a failure, right? Effectively so. And then fast forward a couple more years, and all of a sudden we see incredible things models can do. It set me up for, the ability and right moment and place and time to be able to create Poolside. And so I think there's the classic, job speech, if the dots connect, we only see it in hindsight. I think this was very much one of those moments. And so definitely no regrets. And I'm very glad it brought me to the place that I am right now.
Yeah, I guess as soon as you understand the hindsight bias, you never regret such things, right? But let's come to today. So you're basically now with Jason together founding and operating a company called Poolside that some of us or some of my listeners might have heard of. I wanted to give this episode the title, Let's Build a Foundation Model for Code, Honey. So what you do is basically building a foundation model, like an LLM for code, right? What also obviously is it now turned into a very crowded market, but you were super early. This time not too early, I guess. Anything you want to add? What do you do there?
So, our premise a little over 2.5 years ago was, at the time the world was saying, hey, to reach human level capabilities, to reach AGI and beyond, all we need to do is scale up models, give them more data, do more next token prediction, and we are going to get there. And we didn't hold that point of view from a research perspective. We held the point of view that the scaling of compute was very likely to be directly correlated to the intelligence of models, the scaling of compute during training. but that the missing piece to be able to unlock human level capabilities and beyond was going to become reinforcement learning. And this was a very different point of view on research than the world had, over 2 years ago. Today, I think most of the companies in the foundation model space have gotten around to this in the last 6 months. And so we had our own unique point of view on how to get to human level capabilities in models. Then we said, look, we're going to put on blinders. We're not going to go and care about all the general purpose capabilities that a strong foundation model needs to have, right? The ability to write a great poem or to give the right answer on a medical test. But we're going to focus entirely on the software development capabilities. And the reason this was twofold. On one hand, we felt that software development was a great proxy for AGI and intelligence. It doesn't encompass everything, but it requires good understanding and knowledge of the world. It requires the ability to reason and plan. It requires quite a lot. And secondly, is that our view is that software development was going to become the first major economically valuable activity that was going to get impacted by AI. Kind of from two sides. One, from the rapid increase that we believe models were going to have on reasoning and their software development capabilities. But also from a very simple point of view is that developers have been early adopters of technology for as long as they've existed. And they were going to be the first ones to push this forward and kind of be a canary in the coal mine for all of us. And we were going to see across all knowledge work. And so that's why we've been focused on foundation models. And they are actually very solid general purpose models. You can't build just for code or just for software development. You can't just do code in a model and expect intelligence to emerge. But we definitely bias our models towards their software development capabilities far earlier in their training with far more compute spend on pushing those capabilities.
Wasn't the fact that Jason owned that key to that Arctic vault with basically all the code that was open sourced already, a factor that also counted in, like basically training data availability?
Not so much, because this is the dirty little secret in foundation model building, right? 98% of the data that we use and gather from external sources is publicly available on the web. Right, the data of Git repositories wasn't behind the lock and key. It was available for anyone to Git clone it. And so a lot of people assume that proprietary data becomes a big part of the training of models. And then effectively, the proprietary data that becomes a big part of training foundation models is synthetic data you generate as a company. It is definitely some high value data sets that you do partnerships around. But for software development, the vast majority of what we refer to as pre-trained data in our space is just available to crawl on the web.
Okay, understood. Before we dive deeper, maybe we move a little backwards and zoom out. From your memories, what was the earliest memory when you were falling in love with tech? What was basically your nerd path? Like, why did you get there? Like, why were you doing that?
I don't think I've ever spoken about this publicly before, but it's funny because I was recently reminiscing on this because my parents mentioned it, and I hadn't thought about this. Apparently, when I was about 10 years old, we had one of those, like I think it was a Pentium 1 machine, and we had one of those printers where you still have the hole punch on the side, where just like the continuous page rolled out. I think there were newer printers at the time, but it was just a printer we had.
Like the needle printers.
And apparently I was printing out 100-page manual on hacking and freaking. And I, for the life of me, can't remember which one it was. I think I'd heard about it from some Kevin Mitnick interview or something back in the day. And I was always already kind of messing around with the system, right? Trying to see what you could do in DOS and just essentially kind of hacking things together. And that's kind of where it started. To me, I was a kid who got bullied a lot growing up. The computer at that time was my best friend. It's where I spent all my time on. And it started there and then quickly kind of evolved into someone else in my high school. So maybe a year later, a guy named Dennis, and I still make a point out of sending him a thank you message every couple of years. Because Dennis was an engineer in the Netherlands, was a couple of years older than me, took me under his wing. He said, you're trying to learn this programming thing. I'm trying to write an operating system for these old laptops. This guy was writing in assembly and operating systems from scratch. Completely crazy. No one should do this. No one should be doing this. Even I'm not that old, by the way. I'm 34. So if anyone's hearing this, it sounds like I'm 50 or 60. But Dennis was doing this, and Dennis got smart because Dennis realized that writing the drivers for the keyboard and the screen was going to be a lot of work. So why doesn't he help teach Eiso, this kid, a little bit how to write some assemblies so he can help out? I don't know how much help I ended up being, but Dennis taught me that. And then subsequently, Dennis taught me PHP. So you can't get two more worlds further apart, right? Very high level.
Right, ASM and PHP, that's really weird.
Exactly. But it set me up for just becoming a huge fan of programming and building software. And that evolved into several years later, also wanting to build things for others. So this was on forums back in the day. You would build CMSs for people and you get paid like $100. And then I ended up doing something that quite a few of your listeners will have probably had some touch point with. If you were Googling, this is 20 plus years ago, more, about 20 years ago, probably. You were Googling and you landed on this page that had this very long sidebar of links, like blue coffee cups and red coffee cups in, plastic. And then those pages had a big block of AdSense. And then they have this text that was Markov chain generated, like it was barely readable. I was responsible for a big part of the software that created that. I created something called RSSG, really simple site generator, which was effectively a way, to be very honest, of spamming Google with pages that could rank to the top and had all of these complex SEO networks behind them. But that's looking back from a dots connecting kind of point. That's when I kind of first got in love with text generation, and it was with Markov chains back in the day. And those things just snowballed. Then at the end of high school, I ended up working on a digital currency called Twallers. This was 2008, 2009, so before the Bitcoin paper kind of came out. I became very passionate with alternative currencies. So it kind of a classic beat path of just going from project to project that I found exciting. Some of them monetized, some of them were all very hacky. And then over the years, you learn how to become better at software development. I ended up building, projects and businesses that were always software and tech first. And then all the way to 2015, 2016, when AI caught me because Karpati wrote a post. That's actually how I got into this field.
Okay. And you already explained why you're building your own foundation model, but how does it feel these days? I mean, I mean, you also raised shitload of money, right? You raised also 700 million or something, or almost
626 million. Yeah,
626 million. And I don't know, how many GPUs do you own?
So today we operate 10,000 H200s.
10,000. Wow. So you must be somewhere on the higher end of the list of NVIDIA buyers, I guess. But how does it feel these days? I mean, basically, you entered a space where I would say OpenAI, Google, Anthropic, everyone basically also throws in billions now, or unlimited capacity. How does that feel these days? Do you feel a lot of pressure, or do you think our approach is so different that we have space to breathe? Do you sometimes wake up at night and think, oh shit, what's the news? What's in the news? Whoever published the next codex? How does that feel like?
So I think first of all, if you are working on foundation model and your mission is to reach human level capability and beyond, you are in a constant race, and time to breathe and feeling that you have lots of time, I think is the wrong way to wake up every day in this space. It doesn't matter if you are at OpenAI, if you're at Poolside, I think for all of us, it's the constant race to the frontier. And I think the world in the last couple of years has also gotten around to the fact that we really are on a trajectory to reaching human level capabilities in front of us and across the vast majority of knowledge work, and then even beyond. And so I think it is important, though, to understand what are the ingredients in that race. And for us, we always looked at the ingredients as talent and compute to build advantages in research, engineering, and data. And the advantages are compounding over time. Right? When you're working on models, your last generation model is the foundation for your next generation model. Your infrastructure that you're building, we refer to as a model factory, be able to go quickly from idea to results and evals, is this constant factory that you're building up so that you can build more capable models quickly and faster. And within that, you need to acknowledge one thing, and we acknowledge this from day zero, is that the fuel in your factory is the size of your GPU cluster, or the engine in your factory, or whatever analogy we can kind of think of here together. And the 10,000 H200s fully dedicated towards training, right, of models or synthetic data generation for training or RL for training, like everything that essentially builds a model, is right now one tick away from where the frontier is going to be, and some already is, and where it's going to be in the next 6 to 12 months. And a tick, I mean a magnitude. And so it is our job to make sure that we get there. And this is a really important part. If we don't scale up our compute in an order of magnitude for training over the course of the next, period, we won't be in that race anymore. Now, then the question becomes, what do you have to be able to do to show that you can get there? And here, I think, is where I do sleep. I sleep through the night. I do wake up occasionally at 4 a.m. with, we have to think about this, and then you write it down. I think everyone in tech does. I think it's when you're in a race, that's kind of common.
Unfortunately, yes.
Exactly. And that's about, 4 out of 7 nights or so. But the importance of getting to that next level is about what can you do with no compute? Do you have your scaling laws ready to go? Because a lot of the things that we prove out in our industry, you can prove out at 1,000 GPUs, at 5,000 GPUs, at 10,000 GPUs. So the next scaling axis to unlock as you essentially pour more compute into the things that can improve and scale. And for us right now, that really gets divided between the bread and butter foundation model building, improving the data, scaling up the model size, improving the architecture, everything that is effectively improving compute efficiency or data efficiency. And then really where we think the most important scaling axis right now in the industry is, which is reinforcement.
And how important is it to also build the interface to that? How important is the UI? Is that coming from someone else? Is that ultimately coming from Cursor and Windsurf or others? Or do you also have to do that?
So I think we got to break UI down. If we think about the model, the next layer on top is the agent. Right? Agent to me is model loop environment. It's effectively the model running in a loop, being provided with tools and an environment in which it can execute. Especially in software development, this is very clear, but this holds true as well for agentic products like a deep research product, and frankly, all work that models are going to be doing. We have a saying at Poolside that everything collapses into the models, and we're seeing this. Right? Agents today are increasingly thinner wrappers in terms of code around the model. But what is maybe not yet obvious yet in the world is that the agent experience that you are building for software development, the actual binary, the actual code that gets wrapped around the model with the tools that connect to the environment, is the exact same binary that goes into the reinforcement review. So the way that we are improving models in their ability to build software, reason over it, act, run commands, change files, execute tests, all of the things that essentially encompass software development, is that the product, the agent that you're building, is also the thing that the model is being trained with. And this brings me increasingly to the belief that for areas where foundation model companies can really improve model capabilities with training, is that the best agents, the most capable agents, are going to come from the foundation model companies themselves, because that exact same code with those same prompts is being trained in the model. Doesn't mean there's not tons of
which is basically specs, right? You have specs, and then you generate code and you execute the code and you see if the results are proper, right?
Yes. So the way
to simplify it.
Yeah. So the way RL from code execution feedback, and particularly RL from code execution feedback with agents works, is that you have tasks. Tasks will come in all different shapes and forms, from fix this bug, with 3 words, to build a whole feature, with longer descriptions. Think of this as how we interact, with models ourselves today, and the sheer scale and diversity of those tasks determines like how large of an RL run that you can do. So in our case, we have, I believe, to be the world's largest code execution environment. It's over 800,000 repositories that are fully containerized with their test suite. And in this environment, our model with the agent goes and does millions and soon hundreds of millions and billions of tasks effectively to modify these repos, to fix bugs, add features across the different versions of their suite. And this is teaching the model how to be a successful software development agent. Which then when you bring it out in product form, it's the model with the agent wrapper. But this is why I wanted to break down UI. Because on top of that, the form factor can be many different things. And we have focused on kind of a two-pronged strategy. One, how we want to bring our models and agents to a place that anyone can build on top of them. It's a very API-first centric world. We're getting there. We're not fully there yet, but we're making very fast progress to making that into a place where we want to bring this to the world that everybody can build on top of what we're doing. And then we have our own unique and opinionated views on what a user experience and form factor for software development with AI agents looks like today. And that is an extension to editors. That's a CLI that we will be bringing out. And that is also a view into it from the web assistant. And that's kind of the way to think about it. You have your own product experience, but you want to allow other people to build massively around these because the surface area is massive and the form factor is going to keep changing.
So the simplest form is basically like an editor where you basically code a prompt and then it generates you pull requests, like similar to Codex or other new solutions, right?
I think the simplest form is an agent that's a binary that you can interact with at a programmatic or CLI level. And you provided a prompt, which is usually a form of a task. You provided a target. So that's a code base. And then the third thing is you can provide it in an environment. I think of this as a dev container or a scalable environment where the agent is doing this task in. Not unlike, by the way, what we do with developers, right? Task, code base, environment. I think we can anthropomorphize quite a bit what's happening in models and agents.
If you look at your overall tech, like what would you say is like the biggest secret sauce that you have?
The biggest secret sauce that we have is the one thing we don't talk about, but it's really work that we do in reinforcement learning for non-verified rewards. What we do talk a lot about is our work in reinforcement learning from code execution. And while it's not a secret sauce, I think the scale at which we can do it and at which it operates is very large. I think the second part to the technology that we've built that really is allowing us to keep pushing models to reach the frontier is the way that we build models, this model factory, right? We really go end to end from raw data sources and crawling and ingestion to fully automatically eval models. All of that is built as a factory. So when you're at Poolside and you are working on improving a data set, or you're working on improving the attention mechanism of the model, or you're working on improving the eval set that we're doing, when you make changes there, it impacts this very large directed acrylic graph. That is what a model run looks like. And this is actually very cool because what it means is when you're joining here, you can see this immutable end-to-end system. So the way that manifests itself is I see people do PRs, before the weekend where it's, hey, I'm going to do a big sweep over these different data configurations, over these different attention mechanisms, these architecture changes. And I'm just going to kick off the model factory and let it run 1,000 small models so that by Monday, I can decide which ones of those are most promising. And then I scale them up and I try them out. And this is the thing that's maybe not as obvious to everyone is that model building is really turning into a factory that you build in which all of us operate. We improve all the components in it. Instead of just like every individual new model that you do is starting, in a very artisanal manner. Actually, it's far more about, it's an empirical science and you want to provide the tools to people so that they can very quickly test their hypotheses.
how does versioning of that really work? Like if you say like, I mean, at a certain point you build your new model and then you decide what is good, what is bad. Like how do you version it properly, and how do you like differentiate like or separate the good and the bad?
So it starts with the word immutable. Underneath our entire factory sits an Apache Iceberg data layer, where every single experiment, every trajectory, every model trained is its own entity, and has its own version of the code of the factory. So think of this as a commit hash in a repo. To give you an idea, for a production model run, about 450 different components are chained together to build a production model. So and a single component can be an asset that generates a certain amount of synthetic data. It can be an eval that is happening over the model. But effectively, anytime any experiment gets run or built at Poolside, code gets changed, data gets changed, you have that full end-to-end traceability. The second thing, part of your question in terms of how do you evaluate what's good and what's not, is that you have a big evaluation framework. And for any model run that you do, either small or large, or a big sweep with lots of small models, is that you determine how often you want that evaluation to run. So this can be every, X steps is what we refer to, every 6 hours while the model is training, or only at the end of the model training. And then you get effectively visualization tools where you go in and say, hey, from the 200 variants of model that I just trained on these different data sets, which one performs the best against our evaluation set? Our evaluation set goes from very general types of evaluation, language and reasoning understanding, to very specific software development, capabilities, to very kind of user-facing capabilities. Like, is the model stubborn, or is it able to, respond in the correct style and way that we expect it to? So, good eval set in a model company is benchmarks you've created. It's what we would refer to as automated vibe checks. So these are often real user prompts that have happened in the past, and is the answer correct? And then models as a judge. You use other models to judge the responses of the new versions of models.
And what happens if a training run fails? Like how does that work? Like, is it like really because everything is containerized and isolated? You really isolate the failing use cases, and then you have like a human in the loop that basically double checks it, or like how does it work?
So often we think about foundation model companies as like the big model run that happens. But
yes.
By the time you do but the big model run is actually the smallest part of your time. What's actually before it is thousands and thousands of experiments that get run in the factory before you determine the final recipe, and then you kick that off. And within those, there's tons of failures that happen. There's code that doesn't work. There is, effectively anything possible can fail there because you're working on the system. But by the time you kick off a big model run, something that's running for 2 or 3 months, it's very automated. It's actually very anticlimactic, to be very honest, Toby. What you do is you have now determined your final recipe, your final config, your final version of the code that you're going to use right across your cluster. You allocate your number of GPUs that you're going to use for that. In experiments, all of it is dynamically allocated. So experiments get reprioritized, dynamically allocated. But a big model run, you kind of take your cluster and say, hey, these 8,000 GPUs are only going to be for this run. You put that in your config, you hit enter, and then you sit back. Now, what's going to happen is that about every 48 to 72 hours, some hardware is going to fail. A GPU, what we call falls off the bus, that's the actual GPU error, or something goes wrong in your hardware because the hardware is still quite brittle. At that point, you have several machines that are what we would refer to as hot swap machines that go into an automatic restart process. So during training, there's lots of observability sidecars that observe what the machines are doing, how many errors they're throwing, are they successful? So if something fails, 9 out of 10 times it's an automatic restart, and it will take about 15 to 20 minutes out of your training to do so. Most of that is 10 minutes for observability, like did it really fail? And then 5 to 7 minutes to restart everything. Because a training process is all the GPUs need to be interconnected with each other at all times, if one machine fails, you need to swap that machine out. You do this automatically because you have hot swap machines ready to go. And usually throughout a training run, there will be something that breaks that requires manual intervention. There's something unexpected that could happen on the hardware, but you just have a regular on-call schedule. It doesn't happen very often. It might happen every couple of weeks or maybe 2 or 3 times throughout a big training run. But at this point, compared to several years ago when model building was very artisanal, a big training run is kind of an anticlimactic event. What you do is you sit along the way and you see the evals every day. Right? You're running evaluations. In our case, we run them every 6 to 9 hours. And so you get updated evaluations along the training to see how the model is improving in its capabilities. But by the time you're running a big model run, you're not really going to stop it. You have experimented for every version of your data architecture. You know what you're training. It's extremely unlikely that a month into training you say, "Oh, stop. I'm going to go and do something different." It is highly predictable at that point from your scaling laws what to expect from the model.
Understood. And how do you benchmark? I mean, you benchmark basically your own quality. Do you also benchmark against competitors? Do you benchmark against the market? And how where do you stand there?
So what you effectively do is you have your own internal eval set. There's certain public evals that you think are good that you use. Now, look, a lot of the public evals that are out there 2 years ago were awful. Today, I think there's increasingly better evaluations for software development and reasoning capabilities that are coming out. But it's really important that you don't benchmark hack against those. What I mean by that is if you just focus on trying to get the highest scores on the public evals, you're not going to end up with the best model. That gets you with the best blog post, and then the next day people realize that this model isn't the best one. I think we've seen examples of that in our industry already. But a big part of what you do is on the public evals, you have a really good ability to see how other models have scored and performed. And at times you also run other models to be able to see how they do against your internal evals, right? And your own eval set and benchmarks that you've built. And you use that to get a good sense of where you are in the world. And that's a constant process. And these things are all automated, by the way. This is really important. Every experiment automatically triggers evaluations because you might be. We had a model run that finished post-trained fully by April 2nd with new ones underway. And in January alone, we ran several thousand experiments just ahead of kicking off that model run. So that gives you a little bit of a sense of how automated this process has to be.
And right now, what's your biggest bottleneck? Is it GPUs? And do you want to double down on or double your GPU capacity in the next months, or what is it really? Or is it smart people?
So for us, I think at this point, it's really about scaling compute. And there we think about it not over the next couple of months timeline. We think about, hey, where do you have to be in 12 months in the world, right, to be competitive? And I think that's really important. There's a very, very clear relationship between training, compute, and model intelligence. It can't be ignored. It doesn't mean not all of us are constantly making it more efficient. It's impressive to see how much more we can do with the same amount of GPUs today than you could 2 years ago. But the race is at the frontier, so you're always constantly pushing there. And that's definitely the most important thing. Now, from a talent perspective, we're always looking for outlier people, right, who are incredible across the board. But I would say right now, the most important thing for us in the next 12 months is scaling up to a next order of magnitude of compute.
What was your, let's say, biggest facepalm moment at Poolside? What was there?
There's definitely been a couple. Early on, in the first kind of, when we were 6 people building a model, right? Today we're a much larger team. When we were 6 people building a model, we couldn't experiment with everything. We had very little compute. We were a small team, and we had to make judgment calls on a host of different things that go into a model, right? Because if you think about it, a model is effectively, it's data, right, first and foremost. Then it's architecture, right? Its attention mechanism, its depth of its number of layers, its transformer, non-transformer, etc. And then it is its hyperparameters, its learning rate, its batch size, like those things. And so at least a pre-trained base model. Today things are a little bit more complex, but back then that's how you would look at it. And a lot of that still largely holds true today. And we had to make a bunch of judgment calls. And we definitely had a couple that when the very first model came out of the oven, we face palmed them. We were like, oh, that was stupid. And because we couldn't empirically experiment with everything. And that really pushed us to say, okay, no, never again. You need to have a level of rigor and build a factory where you can really experiment at scale, where you can automate these things. Because working on foundation models definitely teaches you that it really needs to change your intuitions over time. I would look at intuitions that we had on pre-training and models 2 or 3 plus years ago that have, I think, sharpened a lot and have really changed it. And that's because it's an empirical science.
And how do you operate? I mean, I guess Jason is somewhere in the US. You're right now in Spain. Like you're distributed, like fully,
we're fully distributed team. We're about 120 people. Our team sits between the US and Europe primarily. From a research and engineering perspective, our team is on the East Coast of US and Canada and in Western Europe, almost entirely, with a few people just a little bit beyond. That for us was a really important decision we made early on. We said, instead of hiring in the backyard of our competition in the Bay Area, we're going to find the world's most incredible talent that sits outside of it. And we found incredible people all over Europe, incredible people on the East Coast. We have moved people from Asia to Europe as well to join us. And I think that was probably one of the best decisions we could have made. It allowed us to have this incredibly strong team without having the same level of noise that you have in the Bay Area and just a challenge of competition there. Today, I think it's a global market. 2 years down the line, right? Our team is getting recruited by others as well, and vice versa. People are moving, so it's less of a matter now, but it mattered a lot 2 years ago when we started building. But yeah, we operate fully distributed. We do something a little bit unique. Our entire research, engineering, and product org comes together in person every month for 4 days.
Okay, yeah, that's very unique. I just wanted to ask, like, how much synchronous time do you have together? So you also realize that, like, fully remote has its challenges, and especially in such a research-heavy environment, you need to meet up every once in a while, or why did that happen?
Remote is a function of the fact that if you want to hire the world's best people in our field, and you want to do it outside of the Bay Area, you're not going to find them in a single location. You're not going to find them all in London or all in New York or all in Zurich. And so by nature, if you put your talent bar where it needs to be, I think that absolutely you are going to have to be remote. You're going to have to be either in the Bay Area or remote. There's just not really a choice in the Western world for either. So that was, I think, the baseline. Now, remote comes with advantages. It allows people to do a lot of deep work while integrating it with their lives. Right? We're in a race. People work an incredible amount of hours at Poolside. And so being able to do a lot of that remote and integrate it with your life, I think it has allowed people to do so in a way that doesn't burn them out, but still really manages to make a massive commitment to the mission. Then, but still, at the end of the day, if you could have everyone, in the same building, it'd be amazing, right? It just allows for a certain level of communication that you don't get to do with remote. So while remote has certain advantages over being in an office, right? That deep work, being together with each other, having good communication in person, building those relationships, strengthening the bonds so that you can go off and then have a 5-minute chat on Zoom with someone you already know. In person can't be beaten there. And so we take a hybrid approach. And the nice side effect of it is because people are really away from their daily lives for 4 days, right? They travel, they're there, we're fully 100% together and just, working through things. It also means that it's kind of like a shift that you make. It's kind of like as if if you're on a plane or you go on a holiday somewhere, all of a sudden, like you get out of your environment, you have a bit of time to step away, to think differently. And so we've seen that combo work really well. I've been increasingly more excited about it. I think it can work well for lots of companies. It's an investment. It's a financial investment. I don't want to understate that. But I think it gets the best of both worlds. But if you ask me very honestly, if you could have everyone in one place in an office, do I think that it could be even better? I think there's probably a delta there.
You and Jason, you're both like very senior tech leaders. How do you divide responsibilities without stepping on each other's toes?
Very simple. MIT, most important thing. We have so me, Jason, and Margarita, our COO, we run a daily meeting. Every day that meeting starts with what's the most important thing, and then we understand what maps to each other's skill sets. Now there's parts of the org that we've already mapped to like each other's skill sets, and we focus on that. So for me, that's research, engineering, and product. For Jason, that's oriented towards the go-to-market side with our CRO, Paul St. John. But effectively, in this race, you both end up spending lots of time in lots of places. If that's with partners, if that's with customers, that's with investors. And here it just really becomes around like constantly shifting where can each person be most effective, while making sure that your core parts of your business that you're responsible for are on track and have incredible leadership there that can drive a lot of things forwards. But also, I mean, all it just comes down, like if you have, we care about 5 qualities in the company for everyone we hire. And they also hold true for me and Jason and we look at each other. It's low ego, kind-hearted, extremely hardworking, lots of intellectual horsepower, and deeply care about the work you deliver. And that first one, low ego, I think makes it pretty easy to work with each other and divide responsibilities based on whatever's needed in the moment. We're all willing to sweep the floors at Poolside.
When you're stuck, who do you call? Like, is there any mentor in your life, or any other weird sources of advice?
So, first of all, I think having been around for a little while, you definitely have a big bench of people that you call up for different things, right? And a lot of that is often domain knowledge or domain expertise. But the one that is relatively new to me since August, September of last year, is that I finally found a coach that really works, that really has a good impact, I would say, or at least I feel very glad to have. I tried this before, you kind of, I think every couple of years you try coach, and it really never really stuck. And there's a lot about not having found the right coach. His name is Bill Beswick. You can Google him online. Bill is, I hope I'm saying this correct, because otherwise he's going to be upset. But I think Bill is well into his 80s by now, and he's a sports psychologist and former basketball coach. So he had roles with English football club, Manchester United. Trains a whole bunch of primarily athletes. Funny enough, a few people in business, and Bill's been really great to kind of take once a month a pause and talk through everything that's going on in the craziness of AI, of the business, of life, and have him kind of, share mental models, anecdotes, things that help you kind of, think through whatever is the most important thing at that time. And my favorite one of his, Bill usually comes with big stories. When I coach this coach here, or I got this team, and there's a beautiful story, and that kind of, story narratives are a great way to remind you of the mental models to use. But a while back, I had the conversation with Bill around this race that we're in AGI. And effectively, I said to Bill, look, I want to win. And be very honest, he knows this. We want to, Poolside is never just been about software development. Poolside is about, building intelligence and reaching it to a level where we can scale intelligence on compute in the world. It's the most magical thing you get to work on creating. And I said, Bill, I don't know what I would do if I lose. Right? I've just never really thought about it. We're just here, we're doing the work, and And what would I can't think of anything else that my skill set I can go after the next that's bigger. Like this is kind of the ultimate thing to get to work on. And so I was expecting this great anecdote from Bill. If you lose, you go off to the countryside, you do this and like etc. And they always have a nice story. And this time, Bill just like sits there and he kind of looks at me and he's like thinking and he goes, "Yeah, Eiso, just don't lose." It's like I have no like. He's like, "You're right. It's gonna suck if you do. Just don't lose." And that's probably the best advice that I've gotten in a long time. And that hopefully tells you a little bit as well at the culture of Poolside. We're here because we think AGI is in reach. We want to double down towards that. We think there's an incredible form factor to be built around the models as well. We didn't spend much time on this, by the way, for businesses and developers and enterprises. But really at the core, that's really what this is, what this business is about. And he's probably been one of the most impactful mentors recently. But then there's tons of people you call up, investors, executives that you've worked with before and known in the past when it comes to very specific things.
Any crazy learning that you made that you want to pass on to other CTOs here in the last months? Anything that really opened your eyes?
I'll give two. One is kind of maybe an obvious one, and the other is maybe more of something I'd like to stress. So the obvious one to me is when we're building Poolside, we are genuinely in a race. Not every business operates by being in a race. Sometimes you're just competing against yourself or against your runway, but you're not really in a competitive race against others, right? And in my race, it's very clear. It's Google, it's OpenAI, it's Anthropic, it's XAI. That's effectively like the frontier that we're looking to reach and we compete with. And in that race, it is genuinely an existential race. If you lose, you lose, right? I think, and at least that's how we frame it. And when you are very lucky to be able to be in a position where you get to recruit the world's best people to join you on that mission. And a lot of that comes from the fact that we have a lot of capital, and we've been very privileged that people have been willing to give us a lot of capital. And so that also opens up the spectrum of who you get to recruit. Right? Just be very transparent about this. And so when you get to look for bringing along the world's best people on like a very, very competitive mission and race that you're on, there's lots of things from how you do things in a business you can throw out the window. A lot of the processes that we've built in software development are built so that we can operate across the mean, across the average. And when you get to hire these incredible people who you empower, you can start finding, well, what does process look like when I have such strong talent everywhere? Now, that doesn't mean that as you're scaling up, there's not work you have to do on roadmap planning and project management. Not everything goes out the window, but you can actually start taking kind of a view and say, well, let's break some of the rules of how I used to do things. Maybe it doesn't need a daily stand-up. Maybe it doesn't need X, Y, or Z.
No Scrum. Yeah.
And exactly, right? And we've done a lot of stuff in tech over the last years to really build like the best way of doing things. And I do think a lot of them are really good and they're very generally applicable. But it's really worth asking yourself the question of, in a certain team, in a certain setup, do you need to do it exactly that way? And so there's places where I think we've definitely made some changes there. Now, as we're growing as a larger organization, you're also seeing that some of those things have to come back a bit, right? And I think this is something you learn over and over again in tech. Being small is an advantage. And when you have that advantage, don't cargo call all of the big company processes, right? Take advantage of being small where you sit. Take advantage of when you can still do that. So that's probably, I would say, not a recent lesson learned, but it's one that I think comes up over and over again at Poolside. And then the second is, and I've been saying this for several years now, please operate from a place where you assume that in X years, For me, the X is less than 3. Maybe for someone else, it's 5 or 10. But like I personally think it's less than 3. AI is going to reach human level capabilities across the vast majority of knowledge work that we do behind the laptop, including software development. And in that world, what does your organization look like? What does software development look like? And it doesn't mean that there's tons of things you have to change overnight today, but make sure you stay very close to the technology so you can have a sense yourself of how far along we are to that journey. If you're still on the bandwagon of AI is never going to get there, AI is just a stochastic parrot that repeats some statistical things back to me, I really, really urge you to spend time, with the latest reasoning models in the world. Try them out on your tasks and build your own evaluation set so that you can see how the progress goes. Because this is going to fundamentally change the nature of software development. It is going to fundamentally change how we operate, small and large organizations. We are going to be living in a world where we are managing large workforces of agents. I think it's hard to imagine at this point that we're not.
That's true. But like, what will happen in, let's say, 5 years? Do you think we will still write code and review code, or will it be different already?
I think there will always be some people who will write and review code, but I think the vast majority of software that gets built is not because we ourselves are writing the code. It's us managing and working together with agents who are working either with us synchronously, right, real time back and forth, asynchronously, we're sending them off to work and it's coming back to us that we're either reviewing, or even autonomously, places where we place agents that are just working through autonomous tasks, like trying to fix the latest UI bug that got reported, or observing the logs and trying to auto heal and fix the system if it's having an issue. And so I think the qualities in software development for us to be able to think through what to build, how to bring things, what is the agency that we're going to take to make certain changes is key. But a lot of the writing of the code is going to be increasingly done by AI.
Mm-hmm, mm-hmm. And how will we solve the context window issue? I mean, when and how will we solve it? Like, because it feels kind of unsolvable, but I guess it's not, and you have the answer already.
So I will challenge if it's going to be an issue, first and foremost. And what I mean by that is if you think context window as working memory, how much state that you can keep in your own mind, right, or in the state of a model at a request, you realize that our working memory is also relatively small.
Limited.
It's limited.
Yeah.
It's probably not 1 million tokens. Maybe it is for some people, but it's not for me. And the reason I mention this is that when models reach human level reasoning levels in software development and effectively are getting to a place where they can do so, then and they're on a trajectory models to be 100, 1,000 times faster than us. We had I think when we had our call before the podcast a couple of weeks ago, Toby, I think I might have showed you a version of a Poolside model running at 2,500 tokens per second. That's still very much in the research lab, but it's showing us a world where models are going to be able to be so much faster than us. And the reason I mention this in relation to the context window is if you are able to do high quality, reliable reasoning over a multi-step process, you can use the context window you have and offload and onload things onto that stack and off that stack. Right now,
so you basically the model basically decides, hey, this is the context I need to have. So let's switch to this and that file and this and that directory. Yeah,
and let me remember these things from the last trajectory I took, and let me make these things. Let's store these in cold storage where I'm going to only be able to retrieve them from search. Now, I don't think that is the final end state of models. Absolutely, we want models to have continual learning. We want them to be able to have their weights change over longer term memory. We want if an agent is agents are running for years inside an enterprise to be able that the model weights are evolving towards that. And we're doing quite a bit of work towards that side to get ready for that future, where the model weights are individual to the organization or individual to the, one day maybe even individual to the developer if it's getting cheap enough. But I do think that right now we are on a trajectory that increasing the model general intelligence and reasoning and coding capabilities can work around a lot of the context window. And then there's other just very technical details that are interesting, right? We've seen very interesting work on our end by combining the advantages of recurrent neural nets with the advantage of transformers to allow for bigger kind of fixed state spaces. And so I do think that models with much larger context windows than we have today will be something that we'll see more of in the world. But I also think that for many tasks, we're actually going to prefer the model to iterate back and forth over many inference requests faster than try to stuff everything in a massive context window. That's not the strategy we think is a winning.
Yeah, it also sounds somehow like not logic to do that, right? I mean, because also like human are, I think, also not really able to do that, right? Like you can't throw me like a large context and expect me to solve an issue, right?
Yeah. It's again
to spot the issue.
We have a bias at Poolside. We definitely take an anthropomorphized human-like view to the type of intelligence we're trying to build. Doesn't mean that models are the same as humans. There's definitely clear differences, and there's parts where they're really stronger than us, and parts where they'll maybe forever be weaker. But I do think that I don't have a million lane context window, and given enough, if I could do things 100 times faster, being able to use some external tools and external retrieval together with complex reasoning can probably solve for most of what we're trying to solve for.
Cool. What was the most incredible tech you discovered or learned about in the last 6 months?
I'm instantly jumping to the research side, and here I actually can't comment on it. But let me try to find something else from a product perspective or such. It's actually probably not a specific product. I'm just coming back to the phrase of everything is collapsing into the models. I'm finding myself increasingly more and more working directly with the models and the agents that wrap them than actually with other products. I'll give you a very silly example. I have a lot of travel for work, and so my weight had been steadily going up over the last 2 years at Poolside. And I recently decided to do something about it. And instead of using MyFitnessPal or the weight loss tracking app, etc., I decided to just have a daily conversation with the model about what I should be doing. And so I told Poolside, I'm like, hey, this is roughly what I want to follow in terms of nutrition, protein, other things. And throughout the day, I'm having that conversation with it. Should I eat this? This is the menu of the restaurant. What should I pick? Because I'm on the road a lot. And it's been very successful in helping me lose weight over the last 7 weeks that I've been doing this. But I think all of us are finding that the model is becoming a companion, not just in our software development work, but it's becoming in lots of other parts of our lives. And I don't think that means there's not incredible software to be built on top of models. Text and voice are not the perfect interfaces. But that's probably what I continue to be excited about, like discovering the next use case at which you're using intelligence on compute, because effectively what this is. And that's probably, a bit of a non-answer, but hopefully it...
No, it's a good answer. It's a good answer. I still have a little, slowly coming to the end, I still have a little surprise for you, because I also had a pre-discussion with Jason.
Oh, nice.
And he basically told me about like a very early Easter egg in your facepalm model, which is a security hole. Like you can inject commands, and there's one command that he recommended me to inject, because like that's one thing that only your model can do, and that's also the reason why like it's very popular, or was very popular internally. It's the time machine feature, which basically, or it's basically possible to inject like a command to travel back in time. And imagine we now are doing that. Like we inject the command, and we're jumping back to 2016 when you're building sourced. Like basically you just started, right? And you're trying to convince the world that language models can write code. And you now have the chance to whisper something into young Eiso's ears. What would you whisper?
Ooh, I would essentially tell it, you're right. Language modeling plus RL can go all the way to human level capabilities. Forget everything else that you're, like we were building product around, like all of these things, like just keep doubling down, never stop. Right. And probably, and on top of that, I would throw, skill compute. If it's 2016, I would also tell it about transformers. So if it was a little bit later, I would, we were already on there, but I would tell it like, hey, LSTMs are not going to go all the way. So I would either give it the recipe of transformers plus, but a lot of this is a little bit the 4-minute mile. Right. This is I think we hold a debt of gratitude to OpenAI because it proved the 4-minute mile. Right. And if it wasn't for that, I wouldn't have been able to get back into the space. And so I think this is an important thing. I think I would have just tell ISO that it's a 4-minute mile. Like it can be done. It's going to be done. It's going to be done on November 2022 by someone else. Scale up next.
Do it earlier.
Scale up next token prediction and trust your gut on reinforcement learning plus language modeling. All right, that's what we started working on reinforcement learning and code execution feedback back then in combination with the early language models, LSTMs, and then transformers. But a lot of it was just, you were doubting yourself. Like you had this strong conviction, but like, was it a statistical parrot? I got into this space because I read an article by Andrej Karpathy called The Unreasonable Effectiveness of Neural Nets. That launched me into this space. And then a year later, AlphaGo came out. And it's a combination of those two things that just have imprinted on me ever since, like what is possible, right? And that's now a decade ago. And still today, that's actually it. It's the unreasonable effectiveness of language modeling with the scaling of reinforcement learning. And that seems to be the recipe right now. And that's why we built this company and what we're going to keep pushing in the coming years.
I wish you all the luck in the world that you succeed and win ultimately. So yeah, really like crazy ride. Thanks, Eiso, for sharing your story and your thoughts. Really great. Any shout out you want to make? Anything you wanna tell like other CTOs out there?
I think the biggest shout out is we're moving towards a world where we're going to be collaborating with agents. And everything you can do today to spend time with models and agents to get a good sense of where that world is heading is time really well spent.
Thank you. Have a great day. Have a good flight.
Thank you, Toby. Appreciate it.
See you soon. Bye-bye.
Thank you for listening to the AlphaList podcast. If you liked this episode, share it with friends. I'm sure they love it too. Make sure to subscribe so you can hear deep insights into technical leadership and technology trends as they become available. Also, please tell us if there is a topic you would like to hear more about or a technical leader whose brain you would like us to pick. AlphaList is all about helping CTOs getting access to the insights they need to make the best decisions for their company. Please send us suggestions to cto@alphalist.com. Send me a message on LinkedIn or Twitter. After all, the more knowledge we bring to CTOs, the more growth we see in tech. Or, as we say on AlphaList, accumulated knowledge to accelerate growth. See you in the next episode.
Dieser Podcast wird produziert von Podstars bei OMR.